Hi all, welcome to our channel. In this video, part 2 of IUPAC Nomenclature of organic compounds, we are going to see the basic rules for naming an organic molecule as per IUPAC. Let us start with a short recap of what we saw in part 1. Name for a organic molecule can be given as per two systems majorly. The first one is trivial system. For naming a molecule as per trivial system, one requires basic information like its a history, source or something else. And based upon that information, we are going to give the name to the organic molecule. Whereas the second one, IUPAC system, uses a set of rules for naming an organic molecule. As per IUPAC system, the name of an organic molecule consists of four parts. The first one is prefix, which gives us information about the substituents. The second one is root word, which gives us information about the number of carbons that are present in the given organic molecule. The third one is primary suffix, which gives us information about the degree of saturation, that is, whether the compound consists of all single bonds or else if any some are double bonds or triple bonds. Whereas the last one, that is secondary suffix, gives us information about the priority functional group. So totally an IUPAC name looks like this, with a combination of prefix or prefixes, a root word, primary suffix and a secondary suffix. Now let us see the priority functional group list, and here I have shown the functional groups in the priority order along with their prefixes and suffixes. Now let us see few rules one by one. The first and most important rule is longest chain rule. As per this rule, we have to identify the longest possible chain in the given organic molecule and we have to number that. So we are going to see with the help of example how we are going to number. Here I am going to discuss the same example, the same structure with two different types of numberings, and let us see which one is right and which one is wrong. So let us see the example given here. So as per the numbering that was followed in the first is the number was started from the left side and proceeded towards the right. So the longest possible chain here as shown is having 6 carbons, because of which the root word became hex and the degree of saturation is N and the substituent is ethyl that is attached to the second position. That's why it became 2-ethyl hexane. Let us see the same molecule with a different type of numbering. Whereas here in this the numbering was started from the topmost carbon and followed like this, and as per this the longest possible chain is having 7 carbons, and so the name became 3-methyl heptane. So as the name suggests, longest possible chain, as here it was identified 7 whereas here it was identified 6, and so obviously this is having the less number of carbons, that's why it is wrong, whereas this is the longest possible chain and that's why it was correct. So likewise, let us see few more rules. The lowest number rule. As per this, the substituent should be given the least possible number. Let us see the example. Here, numbering was started from the right side and proceeded towards left. As per this, the substituent got the third position. That is, at third position, there was a substituent methyl, and as the total number of carbons are 4 here, that's why it is butane, and the total name is going to be 3-methyl butane. Let us see the other variant of naming for the same compound, where the numbering was started from left and proceeded towards right. Here, the substituent got the least number when compared to the first type of working out. So, here it got 2-methyl butane. As the rule suggests lowest number, so the second workout got the least number, so it is going to be correct, and the first one is the wrong one. Let us proceed to the next rule, lowest sum rule. If the given molecule is having more than one substituent, then the summation of that all substituent numbers should be the least possible. Let us see what does it mean. Here in the given example, the numbering was started from the right and proceeded towards the left, where there are 3 methyl substituents, one at the second position and 2 other are attached to the fourth position. So the molecule can be given a name like 2,4,4 trimethyl pentane. Let us see a different type of workout for the same example, where the numbering was started from left and proceeded to the right. And as per this type of numbering, as per this type of workout, there are 2 methyl substituents that are attached to the second position, whereas 1 methyl substituent to the fourth position. So the name will be 2,2,4 trimethyl pentane. In both the conditions, trimethyl pentane is going to be same, but the substituent numbers or positions or location is going to be differed. As per this rule, the sum of these numbers, that is substituent positions, should be the least possible. Let us see that. So here, the first workout, the total, that is 2 plus 4 plus 4 is 10, whereas the second workout, it is 2 plus 2 plus 4, that is 8. So obviously, the lowest sum rule, as per this rule, the first workout is the wrong one, whereas the second workout is the right one. Now let us proceed to the next rule, that is arrangement of prefixes. Most probably, when we see few students trying to write IUPAC nomenclature, they used to write the name as per the numbers, that is substituent positions, but the prefixes should be arranged as per their alphabetical order, not as per their position. Let us see how. So here in this workout, where the numbering was started from left and proceeded towards right, where it is having 6 number of carbons in the longest possible chain, and at the second position there is a methyl substituent, at a fourth position there is an ethyl substituent. Here they have written as per the substituent position. They started with a 2 followed with a 4, so the name become 2-methyl 4-ethyl hexane, which is wrong as per the arrangement of prefix rules, which need to be arranged as per the alphabet. Let us see the second workout for the same example, where the numbering is same, that is started from the left, proceeded towards the right, whereas while writing the name, it was started with the first alphabet, that is E, where it was attached to the fourth position, So 4-ethyl and 2-methyl hexane. In the first workout, the substituents were written as per their substituent position, whereas in the second workout, the substituents were written alphabetically. And so the first one is going to be wrong, whereas the second is going to be the correct one. If two different groups are located at equivalent positions, then we have to choose the type of numbering which gives the least possible number to the substituent which comes first alphabetically. Let me show it here. So in this, when I have started numbering from either side 1, 2, 3, 4, 5, 6, if I have reversed this, it will be 1, 2, 3, 4, 5, 6. So there are two substituents at a third and fourth positions. Whatever the direction I am starting the numbering, the positions of the substituents are not going to change. They are going to be 3 and 4 only. So in such a condition, we have to prefer the numbering which is giving the least possible number to the substituent which comes first in alphabetical order. So the name becomes 3-ethyl 4-methyl hexane. If the numbering was started from right side, then it will become wrong. In this condition, let us follow to the next rule, where the numbering should be given to the functional group. Least possible number should be given to the functional group in any case. Let us see the examples. Here, the numbering was started from the left side followed to the right side, where the functional group, that is hydroxyl group, got the fourth position. So as per this, the name of this compound became 2,2 dimethyl pent, as there are 5 carbons in the longest possible chain, pentane. As the functional group was attached to the fourth position, it was 4-OL. OL is the suffix for hydroxyl group. Let us see the different type of numbering for the same molecule, where the numbering was started from right and proceeded towards the left. Whereas here, the functional group was given at second position, whereas the other substituents at fourth position. As per this, the IUPAC name of this is going to be 4,4 diethyl, 4,4 dimethyl pentane 2-ol. So as the functional group should be given the least possible number, obviously the first workout is a wrong one and the second workout is the right one. So if multiple functional groups are present in the same molecule which are identical, then we are going to give prefixes like di, tri, tetra based upon the number of groups. Let us see an example. Here, as per this, there are two functional groups that are nitrile functional groups. So here the position of the nitrile functional groups is 1 and 4, and so as the total number of carbons are 4, it was started with butane and 1, 4 dinitrile. Like this, if they are 3 functional groups, then we are going to add tri. If there are 4, then we are going to add tetra. Now let us see nomenclature of few unsaturated hydrocarbons. Coming to the first, which is having 4 carbons and 1 double bond. So the numbering was started from left and proceeded towards right, because the least possible number should be given to the double bond. So as per this, as the double bond started from first position, first carbon, and total number of carbons are 4, the name of this molecule will be but1-ene. But stands for the total number of carbons 4, whereas 1-ene stands for the double bond which was started from first position. Here, this compound becomes an alkyne as it is having triple bond. In this compound, from where we were starting number, either from right side or left side, both is going to be same. So I have chosen to start from left, and so the molecule got the name but2-ine. Because there are 4 number of total carbons, the word but, and as the triple bond was started from second position 2-ine. If there are multiple double bonds, then the same rule as per the identical rules is going to be applied, where depending upon the number of double bonds, we are going to add di, tri, tetra, etc. like that. So in the given example, there are 2 double bonds. That's why I have added di-ene. And these 2 double bonds were started from first carbon and third carbon. So 1,3 diene. And the total number of carbons that are present in the given molecule are 5. So penta 1,3 diene. So let us see naming an polyfunctional group containing organic molecule. In such case, as I said, the priority functional group will be considered as suffix, whereas remaining all functional groups are considered as prefixes. Let us see an example. This is the decreasing priority order of functional groups, and this is the example what we are going to give in name. It is having 2 functional groups. The one is carboxylic acid and the another one is aldehyde. As per this order, carboxylic acid comes first and aldehydes comes later. So carboxylic acid is going to be the primary functional group, whereas the second one is going to be a substituent group, which we are going to denote it as a prefix. So with this note, we can write the name of the given molecule as 4-formyl butanoic acid. When aldehyde is about to represent as a prefix, then we have to add the word formyl. And whenever carboxylic acid was our primary functional group, then we have to add oic acid. So with this, as there are total 1, 2, 3, 4 carbons, it became butanoic acid. So the name is 4-formyl butanoic acid. With this, we have completed the basic rules for naming an organic molecule as per IUPAC system. Thanks for watching video. Please do comment, subscribe.